Hi everyone. Welcome to the Geeky Minds, your source for things related to system design and back-end development. If you are new here, I'm Gourav, a back-end developer and your new friend in the tech world. Let's explore and learn about system design and back-end development together. Don't forget to check out my blog, https://thegeekyminds.com for even more great content. And please don't forget to like, comment, and most importantly, subscribe, so we can continue this amazing journey together. So grab a cup of coffee, kick back, and let's get started.
How message queues increase the reliability of the system. In today's fast-paced digital world, having a reliable system is of utmost importance. A system that can handle a large number of requests and can function efficiently even during high traffic is the need of the hour. This is when message queues enter the picture. In this post, I will tell how message queues improve the reliability of the system and why they are essential for developing a robust design. Let's dive right in. What are message queues? Message queues are a type of software architecture that facilitates communication between different applications or systems. They act as an intermediate between the sender and the recipient, keeping communications until the recipient is prepared to process them. This helps decouple the sender and receiver, hence increasing the system's flexibility and scalability. Purpose of message queues. Message queues enable applications to quickly send and receive messages without interruptions or delays. It ensures the consistency and reliability of data through centralized management. The primary objective of the message queues system is to simplify communication between different application packages or components. This makes it easier for developers to correctly create, handle, store, and process massive amounts of data. Message queues lessen the complexity of individual components by offering asynchronous message delivery. This enables communication between programs even when they are not directly coupled. This enables the application components to remain isolated from one another while delivering their messages fast and reliably. How message queues work. The basic idea behind message queues is to provide a buffer between the sender and receiver. This buffer allows the sender to continue processing without waiting for the receiver to be available. Here's how message queues work. Message creation. A sender application creates a message containing the data it wants to send to a receiving application. Message queue. The message is placed in a message queue, which acts as a buffer between the sender and receiver. Message delivery. The application that receives the message retrieves it from the message queue and processes it. Acknowledgement. The receiver sends an acknowledgement back to the message queue. This confirms that the message has been processed and can be removed from the queue. Message persistence. If the recipient is unavailable when the message is sent, the message queue can hold the message and re-attempt delivery at a later time, hence preventing communications from being lost. Load balancing. Multiple receivers can be connected to the same message queue, enabling load balancing and failover functionality. Overall, message queues provide a dependable, scalable, and asynchronous communication mechanism for applications. Message queues allow applications to continue working without waiting for each other by decoupling the sender and receiver, hence enhancing the overall performance and dependability. How do message queues increase the reliability of the system? Message queues are a vital part of the cutting-edge machine structure. They provide a dependable method for processing and delivering data among several programs or services. Message queues allow applications to communicate in real time and to process requests asynchronously. This boosts the machine's reliability as it is not dependent on a single component always being present and functioning. Message queues also contribute to the scalability of the device, as they can handle a large number of requests without overloading a single system node. Using message queues, we can ensure that each responsibility is completed swiftly, reliably, and at scale. Advantages of using message queues for system reliability. Message queues allow us to process massive amounts of data asynchronously, preventing the device from becoming overloaded with requests. Message queues also allow us to store and process messages without having to modify the current architecture, which means we can utilize message queues without having to rewrite our entire program. Message queues can also be used to maintain order inside a distributed system, ensuring that all jobs are completed sequentially and no commitments are ignored or forgotten. Here are the advantages of message queues. Load balancing. Message queues are an efficient means of distributing load among multiple applications. This ensures that no single program is overloaded with requests, resulting in increased dependability and performance. The message queue functions as a buffer, enabling applications to process requests at their own rate and decreasing the likelihood of a system crash or failure. Asynchronous processing. Message queues permit asynchronous processing, meaning that the sender and receiver do not need to be online simultaneously. The sender can place a message in the queue, and the recipient can retrieve it whenever it is ready. This minimizes the requirement for real-time communication, resulting in increased performance and dependability. Improved fault tolerance. Message queues provide a method for handling system problems. Messages saved in the queue can be forwarded to a new application or system in the event of a failure, ensuring that the messages are not lost. This increases the system's failure tolerance and improves its reliability. Decoupled communication. Message queues enable the sender and recipient to communicate independently. This indicates that the sender is not required to wait for a response from the recipient before executing the subsequent request. The receiver is able to process messages at its own rate, resulting in higher reliability and enhanced performance. Conclusion. Message queues play a significant part in enhancing the system's dependability. Message queues provide load balancing, asynchronous processing, enhanced fault tolerance, and decoupled communication to ensure that the system can efficiently handle enormous volumes of traffic. Implementing message queues into your architecture can significantly enhance the system's dependability and performance. And that's a wrap. Hi, I am Gourav Dhar, a software developer, and I create content on back-end development and system design. Subscribe to my channel and learn something new every week.